Hello, dear students. Welcome to a new chemistry session in Chapter 4 entitled Chemical Reactions. At the end of this video, you will be able to distinguish between stoichiometric and non-stoichiometric mixture, define the limiting reactant, identify the excess reactant in a chemical reaction. You need in this session your chemistry booklet, your chemistry notebook, and a pen. Studying the quantitative aspect of chemical reactions in industry is very important to avoid the products overlap and economic loss. But how to calculate the exact proportions of the chemical species in a reaction to avoid products overlap and economic loss? Let us make an analogy with a grilled cheese sandwich preparation. To prepare a grilled cheese sandwich, 2 bread slices and 1 cheese slice are needed. How many cheese sandwiches can be prepared if 4 bread slices and 2 cheese slices are available? 2 cheese sandwiches. How many cheese slices are needed to prepare 5 cheese sandwiches if 10 bread slices are available? 5 cheese slices. We depend on the first equation to know the other proportions. This equation is called the balanced equation of the chemical reaction. In the balanced equation of the chemical reaction, the numbers 2, 1, and 1 are called stoichiometric coefficients. The stoichiometric coefficients are the smallest natural numbers that indicate the proportions with which the reactants undergo the reaction and obtain the convenient products. What is the maximum number of cheese sandwiches that can be prepared from 6 bread slices and 3 cheese slices? 3 cheese sandwiches. What ingredients are being totally consumed? Bread and cheese slices are being totally consumed. So, 6 bread slices and 3 cheese slices give 3 cheese sandwiches. The reactants are totally consumed, and the final mixture contains the products of the reaction. This mixture is called stoichiometric mixture. Let's find the ratios of the quantities of the reactants in this reaction to the stoichiometric coefficients in the balanced chemical equation. 6 over 2 equals 3. 3 over 1 equals 3. The ratios are equal. So, in a stoichiometric mixture, the quantities of the reactants involved are proportional to their stoichiometric coefficients in the equation of the reaction. What is the maximum number of cheese sandwiches that can be prepared from 7 bread slices and 3 cheese slices? 3 cheese sandwiches. What ingredient is being totally consumed? The cheese slices. What ingredient is not totally consumed? The bread slices. Find the quantity of the ingredient that remains. 1 bread slice remains. So, 7 bread slices and 3 cheese slices give 3 cheese sandwiches and 1 bread slice is left. The cheese slices are consumed, but the bread slices are not totally consumed. The final mixture contains 3 cheese sandwiches and 1 bread slice is remained. This mixture is called non-stoichiometric mixture. Let's find the ratios of the quantities of the reactants in this reaction to the stoichiometric coefficients in the balanced chemical equation. 7 over 2 equals 3.5. 3 over 1 equals 3. The ratios are not equal. Therefore, in a non-stoichiometric mixture, the quantities of the reactants involved are not proportional to their stoichiometric coefficients in the equation of the reaction. In a non-stoichiometric mixture, the bread is not totally consumed. An excess amount remains at the end, so bread is the excess reactant. However, the cheese slices are totally consumed. It limits the maximum quantity of sandwiches produced, so it is the limiting reactant. The final mixture contains the products and what is left from the excess reactant. In a chemical reaction, there are different steps that should be followed to determine whether a reaction mixture is stoichiometric or not. The steps that should be followed are: balance the given chemical equation if it is not balanced, express the given quantities in number of moles, find the ratios of the reactants. The ratio of A, it is equal to the initial number of moles of A over A. The ratio of B, it is equal to the initial number of moles of B over B. Compare the ratios of the reactants. If the ratios are equal, then the mixture is a stoichiometric mixture. However, if the ratios are not equal, then the mixture is a non-stoichiometric mixture, and the smaller ratio corresponds to the limiting reactant. In a chemical equation, the stoichiometric ratios SR are written in this way: number of moles of A reacted over A equals number of moles of B reacted over B equal number of moles of C produced over C equal number of moles of D produced over D. The stoichiometric ratios are used to calculate the exact quantities of the chemical species in a reaction. Thus, products overlapped and economic loss are avoided. Back to chemical reactions. Let's do applications together. Is a mixture made up of 0.27 moles of N2 and 0.81 moles of H2 stoichiometric or not? Write the balanced chemical equation of the given reaction. N2 plus 3H2 gives 2NH3. Find the ratios of the reactants. Ratio of N2 equals number of moles of N2 over 1 equals 0.27. Ratio of H2 equal number of moles of H2 over 3 equals 0.81 over 3 equals 0.27. Compare the ratios of the reactants. Ratio of N2 equals ratio of H2. Deduce whether the mixture is stoichiometric or not. Since the ratio of N2 equals to the ratio of H2, then this mixture is a stoichiometric mixture. For this stoichiometric mixture, find the number of moles of ammonia produced. First, we write the balanced chemical equation. The stoichiometric ratios can be written in the form: number of moles of N2 reacted over 1 equal number of moles of H2 reacted over 3 equals number of moles of NH3 produced over 2. Use the ratio of any of the reactants to determine the number of moles of NH3 produced. By cross multiplication, the number of moles of NH3 produced equals 0.27 times 2 equals 0.54 moles. Let's solve another application together. Is a mixture made up of 0.27 moles of N2 and 1.2 moles of H2 stoichiometric or not? We follow the same steps. Write the balanced chemical equation of the given reaction. Find the ratios of the reactants. The ratio of N2 equals number of moles of N2 over 1 equals 0.27 over 1 equals 0.27. Ratio of H2 equals number of moles of H2 over 3 equals 1.2 over 3 equals 0.4. Let's compare the ratios now. The ratio of N2 is 0.27 less than the ratio of H2, 0.4. Deduce now if the mixture is stoichiometric or not. Since the ratios are not equal, then this mixture is a non-stoichiometric mixture. Let's identify the limiting reactant and the excess reactant. Since the ratio of N2 is less than the ratio of H2, then N2 is the limiting reactant and H2 is in excess. Let's determine the number of moles of H2 reacted. The number of moles of H2 reacted can be determined by stoichiometric ratios using the ratio of the limiting reactant N2. By using stoichiometric ratios, the number of moles of N2 initial over 1 equals number of moles of H2 reacted over 3. By cross multiplication, the number of moles of H2 reacted equals to 0.27 times 3 equals 0.81 moles. Let's determine the number of moles of NH3 produced. Moles of NH3 produced can be determined by stoichiometric ratios using the ratio of the limiting reactant N2. By using stoichiometric ratios, the number of moles of N2 initial over 1 equals number of moles of NH3 produced over 2. By cross multiplication, the number of moles of NH3 produced equals to 0.27 times 2 equals 0.54 moles. To sum up, a reactant mixture could be either a stoichiometric mixture or non-stoichiometric mixture. In a stoichiometric mixture, all the reactants are totally consumed and converted to products at the end of the reaction. However, in a non-stoichiometric mixture, we have a limiting reactant and an excess reactant. The limiting reactant is totally consumed. It limits the amount of products produced. However, the reaction will stop when all the limiting reactant is consumed. The excess reactant is not totally consumed when the reaction stops. That's to say, a quantity of it remains at the end of the reaction. Dear students, carry out this assignment, read worksheet 18, resolve the applications solved in this video on your chemistry notebook. Thanks for listening.